Hello everybody and welcome to this webinar by OPSWAT. I'm Millington, I'm one of the Director of Products specialising in cross-domain.
Hey everyone, I'm Prrikage. I'm one of the product leaders here at OPSWAT. I'm the VP of Products. I oversee the file security group and cross-domain is part of my group. But before we jump into the cross-domain and what our recommendations are and our best practices in that environment, just 2 seconds on what is OPSWAT doing on the cybersecurity and especially on the cross-domain. So our mission is to protect the world's critical infrastructure. We're a cybersecurity company, been on the market for over 20 years. We do have a focus in both enterprise, but also in government with more focus on defense intelligence community. Now, before we start, I want real quick over the agenda. We're going to touch based on like what is the cross-domain solution, what are some of the challenges there, and like why people are trying, or like agencies and environments are trying to bypass that a little bit because it's a bit more challenge to like manage those environments and so on. Why it became so popular to design a more flexible cross-domain solution, how that should look like, and also a couple of things that we've seen based on our experience working with these environments for over a decade on different use cases, but also what they were looking from flexibility and manageability perspective. Now I'll pass it to Val to walk you through a couple of things based on her experience in cross-domain.
Hi, thanks George. So why do we need cross-domain? Cross-domain has always been required, despite the best security efforts to say, browse to data, don't transfer data, we just want our data. And as our operations environments and our enterprise environments within government and defense become more elaborate, we just have more need to actually share data and collaborate data between security classifications. It's never going to go away. But what we need to do is to ensure that the systems transferring that data, allowing that collaboration, can do so and keep that data as safe as possible, preserving the integrity of those higher side environments where essentially your really sensitive data assets are kept. So let's have a quick look at what we're now seeing when people want cross-domain. It's changed quite a lot over the years. Traditionally, we would have data transfers between an endpoint and another endpoint in a higher domain, one on the lower domain, and we might have some file shares, low side, file shares, high side. We may have specific types of files, specific data types, smaller volumes, but very static, very well-defined transfer requirements. Now we're seeing the use cases expand. We're seeing use cases get added to existing gateways. We're seeing a range of files being transferred that we haven't seen before. We're seeing import particularly blossom in terms of the types of files. We're also seeing the concept of dev low, deploy high. Export is still there, but of course, export now, we have to be really careful what we're trying to send down to these lower security domains. Essentially, cross-domain is now multi-volume, multi-type, multi-application to application, API to API, cloud storage to high side on-prem across all the tiers. In the UK, that's official, secret, top secret. That obviously varies from region to region, but the ideas and the needs are the same. We want to transfer data, we want to do it safely, securely, and rapidly, and we often want to do it at volume. Now, handing back to George, just briefly.
So maybe like one thing I want to like discuss, to like touch base on the previous slide as well, is like we're seeing a lot of increasing volume, as Val mentioned, but it's also a matter of like the file types and so on, right? So there are like system files, right? Like Windows updates, RPMs, applications, all the installers, firmware updates, whatever that might be on the high side, but also part of their CI/CD. There's a lot of like low-end development they need to bring in and deploy on the high side as well. So think about those environments are no longer just like a file repository with like 10 top secret PDFs, right? We're talking like very large deployments on top secret side, maybe, or secret and so on, where they have a lot of applications, they have a lot of interactions between, as Val explained, and so on and so forth. And definitely there's the productivity files, right? Like from email traffic to, I don't know, Word, Office, I don't know, Office documents, PDFs, images, and so on and so forth, satellite images, whatever that might be. Now, a couple of things here as well when we're talking about like data exchanges, right? There are different things, different expectations. So there are like different definitions on cross-domain, but they're very similar to each other, especially when it comes to Five Eyes. There's a lot of closer relationship between them, right? There's the NCSMO in US, then NCSC in UK, and so on and so forth. Each of them have a different flavor. What they expect is like, as you see, they're like security enforcing functions. But in a nutshell, they want to make sure that the traffic is properly validated, it's properly filtered, and how many filters you apply as part of that. I don't know, cross-domain capability, right? So at the end, they're clearly defined on what are the expectations and also how many filters. But at the same time, there are things depending on the traffic and depending on how this is getting deployed, where in the environment and so on, there might be some loose definition on like how do you want to enforce it. Now, there's certain things that need to be set in stone, right? Nobody wants to make like I don't know, disable everything just like easily bypass. But for me, and this is part of our experience in the past as well, people try to like find a way to tick the box and move on because, and this is valid everywhere, not just in across domain. When security gets in the way, people are trying to figure out ways to bypass it, right? So that's where I think the complexity across domain solutions brought in. People are trying to put it, I know, I think Val explained a little bit earlier on, like an endpoint to endpoint. I'm going to receive a file, I'm going to put it on disk. If the local AV is not deleting it, then it must be safe to consume. So I'm going to move it to the high side and things like that. Those are not cross-domain solutions. Those are workarounds to say that, hey, we're doing minimal checks. Now, that might actually, let's say, be good enough in certain environments. When you're moving from unclassified to classified, secret, top secret, and so on, right? They're like tabby environments, then it's a very different discussion.
So there's three workflows associated with cross-domain, essentially: import, low to high, export, high to low, and then there's browse. We're going to really look at import and export. The key thing when we're looking at import, we're going from unrestricted, unofficial, any lower side environment up to secret or even above secret. Either way, the thing we're really trying to do here, which I think a lot of people tend to forget about cross-domain, is we are focused on protecting those high side assets and that high side environment. That's got to be our priority. Now, to do that, obviously what we need to do is to really focus on trying to flush out any malware, any zero-day attacks as much as we can to try and protect that high side environment. I know people think there's a diode, therefore it's enforcing a single point of entry. Well, that is true to an extent, but the real thing here is that we are trying to protect that high side environment. Export, slightly different nuances here. Yes, we assume a level of data cleanliness, rightly or wrongly, but what we really want to look at here is we want to look at correct release of data. What we don't want is data leakage. We don't want data to be incorrectly released. And if it is incorrectly released, we really want to know who or what gave that authorization to do so. So the controls are slightly different. What we're really looking at here is to try and ensure data that someone has asserted can be released is legitimate for release. So if we've still got something marked, for example, at top secret and it's being released down to, let's just say, a confidential environment, then obviously that should not be released. Categorically, it shouldn't be released, and that's very obvious. But we want to know, and we need systems in place to ensure that cannot happen. And this is what we're really focusing on with export. Now, the other thing we're now starting to see, as we've mentioned before in cross-domain, it's no longer just what we're calling user-based workloads, more document-based data. We're seeing an awful lot of system-based data. And whilst you think, well, yeah, so what? The big thing here is that really does start to demand you start to view this data with a different set of controls to ensure its validation. So when we go further on in this presentation, we'll show you that we have two different approaches, really. We can look at the user-based traffic for import and export, and we can look at the system-based and software-based traffic for import. Export is a different game, really. If you're trying to shove system data around in an export fashion, it doesn't necessarily work as well, but we'll go through that as well. So let's look at some of the core components of a CDS architecture. So in terms of the security enforcing functions that make up a cross-domain capability, and bear in mind that usually we're looking at two discrete chains. If you're going to have an import, a bidirectional capability, one for import, one for export, you're going to be looking at two discrete chains of security enforcing function. Whether that's in self-contained hardware or not, there'll be separation within those hardware appliances that enforce that separation of the chains. Let's look at some of the functionality. So data transform. Data transform is a really key and important capability. It's often done on the low side of a gateway, but depending on what region and where you are in the world, your architectural patterns may be very different. And they may dictate it's on the high side of a solution or in a DMZ, specifically in a sort of what's nicknamed a diode sandwich, or it may be done on the low side. In the UK, we tend to do a little bit on the low side. Sometimes we may do more on the high side as well. But the data transformation is a key piece. And there's two reasons for that. One, we want to get data that is more complex into a really flat structure. The flatter it is, the simpler the structure is, the better chance we've got of really trying to inspect and validate that capability. And why do we want to do that? Well, that allows us to look for data that, or remnants of data that really shouldn't be there. Now, if you think about malware, malware is inherently fragile. So with that fragility, if you undertake a transformation, you can actually start to disrupt the malware content, if there's any there, from the get-go. And that's a really powerful and a really strong tool to use in cross-domain. But it's not always practical. Okay, a lot of capabilities, particularly more on the system-based file data types, are just not transformable. And there's other techniques we can use to apply a rigor to them when we inspect them. Moving on, let's look at the unidirectional control. Now, that's a diode to everyone else. Okay, that's a diode or a dioding capability. Diodes, two flavors very briefly: FPGA, optical. Okay, there are other variants, but they're not as they're not considered strong. They're not considered as strong as those two technologies, FPGA and optical. In terms of the protocol breaking is there to really stop the piggybacking and the replay attack approach in terms of protocol breaking techniques. So really what we're after here is to really look at that transport, and there's 7 levels, so 4 and 7 of the OSI model, and we're really looking at what we can do to stop those replay techniques taking advantage of those protocol packets. And often it can be very simple. We can transform to a proprietary protocol, or we can even just transform to another known network protocol. That's equally as acceptable. Getting back to the diodes briefly. So the diode may not just be a diode itself, it can be in a data guard. And either way, it is that capability that enforces that one-way flow and thus protects the high side environment by limiting backflow, or eliminating backflow really, if that is your only ingress point. As we go higher up in a chain for cross-domain, we end up on the high side, and we would want to do some kind of content inspection. If we've done a data transform, we can really look at the syntactic and semantic capability, and we can really look at tearing those real structures apart to see what is in them, how they are constructed, and how one instruction can follow another instruction, and where those instructions are set to execute. We can really start to look at the content in a very strong way. The CDR capability is relatively new to cross-domain, but is becoming more and more popular. And depending on how you implement it, that can be tremendously strong, because that can really look at the IOCs in a data block and can look at eliminating those potential threat vectors. So essentially what we're saying is that data block there is inherently dangerous if it was to go up to your high side and be executed, even if there's nothing in there. So we can make a decision. Do we take that data block out? Do we analyze it further? Or do we just, based on the risk stance of the environment, strip it out completely? So we have those 3 capabilities that really do allow us to ensure that when data arrives on the high side, we can be fairly sure it's of a good quality and clean. The last one is really an export capability. This is our release control. This is essentially mechanisms, or a series of mechanisms, that allow someone to say, yes, this data can be released down from the high side to the low side, and we are going to conduct certain security enforcing functions against it. That would be things like DLP, data loss prevention, to really ensure that there's nothing in that data that would stop it being released down to a lower classification. These are just 4 techniques that come with additional functionality attached to them to make them enhanced and to make them relevant to the environment that we would use on a day-to-day basis if you're designing a cross-domain capability. Now let's quickly just go through the flows. So we've mentioned 2 flows, import flow and the export flow. Import is probably what you'll see most of. Most cross-domain capabilities really do focus on the import. And this is a big thing. People want to bring data up. Let's just concentrate on the data preparation. So we've just talked about that. That predominantly is ensuring that data, when it comes into a capability to be ingested on the low side of the solution, this is your lower classification, that essentially it is in a state where it can be inspected when it arrives onto the high side. Now, that's, as I said, that's not always possible with data of a system type, but there are other techniques that can be used in terms of effectively wrapping the data to nullify the data. And these are using fairly simple cryptographic standards that you can just scramble the data. And in effect, if you think about what you do to transform, in fact, it's another way of nullifying any malware that may be resident. Okay. Once data has been prepared, you put it through your unidirectional control and protocol breaking. And this effectively is your diode or your data guard capability that has that dioding functionality in it. After that, the data has landed, and that's where we would start to really strip apart the data, look at the syntactic structure, the structure of the whole sort of framework of the data, and the semantic is almost implying the meaning of the data in terms of where terms are put inside that structure. Now, the 2 points on the end, just come to this briefly. It's very easy to forget the ingest and landing methods across domain. And a number of vendors will simply say, well, we're only concerned with that boundary point, either side of that unidirectional control. That's what we're concerned with. Everything else is up to you. From years of doing this, the up to you bit is the bit that can really bite you in terms of integration and mechanisms to do that. So we think at OPSWAT, certainly, it's important to also think about the ingest mechanisms of data, how you're going to get the data to that entry point of your cross-domain chain, but also how you're then going to distribute and land that data in a way that doesn't nullify all the good checks you've just put in place. Moving on, the export flow we've talked about. This is more about this piece of data I want to release. Can I release it? But of course, before we actually sign point 3 here, that we say, yes, this data can be released, and we push it through the unidirectional control, we're actually going to push it through a number of filters to ensure that, yes, absolutely. So if Fred, for instance, said this data can be released, we want to make sure Fred is absolutely correct, that it can be released and that no one has tampered with that data, and it is in a state or a vision that would allow it to be released to a lower classification. Bear in mind, top secret data being released down to official or confidential is a real no-no, whatever region or government you happen to be part of. Okay, so this is why we do this data cleansing, and we then assert that data has been checked. We pass it through the unidirectional control. We apply the protocol breaks again, as we described earlier, to stop any piggybacking attempts. And then we concentrate on what we do with that data once it's landed, who has access to it, and how it's distributed. I'm going to hand back over to George now, who's going to talk through a little bit of the issues we have found with legacy approaches to CDS. Is that okay?
Thank you, Val. Yes. So think about what we've seen so far, and I think we've tried to hint a bit in the past, is that people are going to try to bypass these more complex CDS solutions, right? And the reason for that is that they're very well defined for a particular use case and particular type of traffic and so on. So the moment that environment evolves, the more bottlenecks these systems become, right? And you're seeing there that they're highly static. Now, whoever worked in government, they know they typically define projects like on a project base that it's going to be alive for a number of years and so on, right? There's a lot of movement to be a lot more agile and so on than used to be, right? But if you define something and you're paying a lot of money for it to be in place for the next 5 to 7 years and so on, it by default is kind of like a static solution. And scalability is definitely one of the issues here, right? The bigger you're not able to over provision an environment, but like 5 years from now, that environment is going to look very different and a lot more expectations coming from that pipe, let's say. So it's a scalability issue when it comes to like how much traffic we can push through it, how fast are we delivering that traffic, and so on and so forth, right? And again, the environments evolved a lot, right? As we mentioned before, it was the matter of more productivity files. Now there's also like CI/CD pipelines. There's also like system files and so on. And the volumes for that are significantly higher than you should expect from a productivity file suite and so on, right? So then it's going to be a very long process for you to process all that, and like for those ones to bypass, like to pass and be filtered and so on. And the more you're trying to adapt new technologies and so on for the new reality, so to speak, that is a long process to actually certify, right? So there are like certifications body for you to actually have a define CDS approved solution to be on a baseline and so on. That's quite costly and takes a lot of time as well. And again, I'm not saying that's a bad thing. Definitely, they need to look into all the nitty-gritty because these are critical systems. What I'm saying on the other side is that people are going to try to like find workarounds until they have a proper solution in place. And this is where the biggest challenges are coming into play. So what we try to put together, if we go to the next slide, it's more on what we're trying to deliver on the MetaDefender side. So we built MetaDefender platform as a file analysis pipeline. We have this like layer file protection, as we call it, right? But it's a solution that actually goes and tries to analyze each file coming in based on their true file type, not relying on the extension, and to apply the right technologies for each of them, right? Because an PE, an executable versus an open source or Docker container versus a PDF or an image will have different risks associated with that file. So what we've done from the beginning is to look at every file type and what's the associated risk for each of those. And then as that file is traversing through this pipeline seeing on the screen, different technologies might kick in or not in this case. So maybe let's take two quick examples. If we have a PE file, we're going to check the file type. We're saying, hey, it's an exe file, a Windows application. Then we're checking what's the vendor, what's the signature, country of origin, if it's on a allowed block list. If it's not, then we can move forward, check for vulnerabilities, scan it with our multi-scanning solution, and then we're going to potentially send it to the sandbox if there's a configuration on the pipeline to actually do a deeper inspection on that one. But if it's let's say, a Docker container, we're going to check the file type. We're seeing it's more of a tarball, so we're going to handle it as an archive. So we open that one, we go through all the files in it and so on, and we apply not the file-based vulnerability, but we're going to apply SVM at the end. But beforehand, we're going to apply multi-scanning, we're going to apply proactive DLP to check for secrets in that code and so on, and potentially for sandbox to emulate certain things if we're finding some interesting scripts there as well, and in the end, sandbox. And maybe real quick on a PDF, it's very different because this is a complex file type, but we can actually apply a lot more technology, especially on deep CDR, where Vale was explaining before. It's so important for us to be able to like identify structurally how that file looks like. So think about deep CDR as a structural validation first, and proactive DLP more of a content-focused technology. So deep CDR is going to look at the file structure, depending on configuration, might keep or remove certain objects from that structure and rebuild a brand new file with the approved compliant objects, so to speak. And then we can check for secrets, for sensitivity, and so on and so forth. So we have this kind of like pipeline as the file is traversing, and we're doing this for every child in an archive, any object we can extract from that file, which is definitely more compute intensive and takes more time, but that's how we provide an end-to-end security for what we call the file security flow. You go next. And we're applying this one to different channels, right? And I think this is the important part where we have the technology, we have MetaDefender platform, but then we have like different ways to like ingest the files into the platform, right? So depending on the use case, we're going to discuss about the use case we're seeing in cross-domain in a second, but depending on the use case, this can be like REST API integrations, but can actually be, I don't know, monitor a storage unit, might be an NFS or SMB share, but also can be, I know, as Val mentioned before, maybe you have, I know, let's say a cloud solution, I don't know, SharePoint or OneDrive for unclassified, and you want to push some of that one on a higher environment. You want to like replicate that one on-prem in an air-gapped environment. How are you going to manage that one? If you need to build your own custom I don't know, API integration, maintain those scripts and so on, we offer everything out of the box. So the goal for us is to apply that layered file security solution and to have an entry point, let's say a solution for every data entry point organization, being a USB, being a container registry or a code repository, being a file storage solution, and so on and so forth. You can go next. Maybe Val, you can talk a bit more on like why this modular approach will be a good fit.
Absolutely. No, that's great. So you've seen how we layer up our security enforcing functionality. That is entirely tailorable. We can have multiple flows going through a single core. We can have different cores depending on high and low side and what you actually need. And in a minute, we'll look at some use cases where we can actually talk through some of the splits we've got of MD cores. But essentially, the big thing we've got here is that what we try and say is that we're not going to say to you, absolutely, it's OPSWAT or nothing. What we can do is we can enhance an existing cross-domain capability, adding in more richer features to enable a greater volume and greater types to be accepted through the gateway. We are software defined predominantly, and we've coined this phrase, ugly as it is, plug in, plug outable. What that means is that you can tailor a specific set of flows, and you can have multiple flows going through a core that will deal with specific data types according to your risk balance scenario, what you need to meet to get the accreditation for your cross-domain capability. We can be deployed in a range of environments, so it's no longer a thing not to be mentioned, but essentially, yes, low sides can be in the cloud now. It's fairly common that low sides will be in the cloud. It allows a greater collaboration, and it can be seen as allowing a greater flexibility. So we have our capability that can also be in the cloud. We've also adopted a term, how we try to picture across the main gateway. It's a bit more like a laundrette, really. We have a pre-wash capability. Depending on which region you are, some people will want more on the low side, some countries and regions want more on the high side. But either way, we can tailor that. And then you can have another core on the high side, and we can then have that as an on-prem in an air-gapped environment. So we work across all those platforms. We can integrate with a range of hardware as well. We have our own, which we think are very good, our network optical diodes and associated diode products. But we can also integrate with a range of other diodes and data guards as well. So effectively, as I said, we can enhance existing hardware-driven cross-domain gateways. Because we're software, because we work around this core, and this is a thing, I've got to be honest, that really attracted me to this portfolio, is because you can set up workflows, you can integrate them, you can do it within minutes. Now, that is quite an offering if you have come from a background like mine, where you've done a number of cross-domain gateways, and effectively it's the integration that always tends to be the bitey bit at the end of a program. You can buy all the bits, plugging them together, it's never as simple as you think. Scaling them almost impossible. But with something like MD Core, the plug-in, plug-out ability, it's very easy to scale, and it's very easy to tailor-make it according to what you need.
I think maybe one quick to add there, if I may add. I think that's very powerful, the fact that nobody has all the workflows and all the data flows outlined from the beginning of the project, right? Based on the experience I've seen, especially in the recent years, they're deploying something, and then there are more teams that are coming in and trying to use that flow, and they have like different requirements on how that flow should look like, what kind of files, what deliveries, and so on, right? And one example that I love from one of our customers, like, I cannot have the same flow for a 2-star general that expects to get its file within less than a second, then for me to scan all Windows updates, cap files, and so on and so forth. So definitely needs to be a very different, priority queues, like set workflows on like things that are more urgent versus things that are like can go during outside working hours, weekends, and so on.
No, absolutely. It's a great point. It's a great point. And this is one where I think people, when they imagine a cross-domain gateway, they think very linearly and they think in single chains. And that's not the world we live in anymore. We have multiple flows coming through a gateway. And if you design it in such a way that it's a more stovepiped, overly hardware-based, let's say, capability, then essentially you start to throttle what you can do with it. So you start to throttle it, as George has already mentioned. People find ways around it. Okay, it doesn't have great user uptake, and it's very difficult to expand. We think the software-defined approach with selected hardware elements is something that we support very, very well with our MD Core based capability, and something that allows the expansion and the development, and as George said, the realization of multiple flows that may not be locked down at the time of early design. Now what we're going to do is we're going to look at some use cases. We've got some key government use cases here, and these are multiple workloads, low to high predominantly, so import. CI/CD, which is one that's becoming more and more popular. And then we're going to look at a very quick export case, essentially. People still use media. People still use good old USB sticks, absolutely. And it's quite a common case where people will want to bring data in off a stick or share data to a stick. We're just using this option to really try and walk you through an export capability. So let's start with the multiple workload types. It's a fairly simple one. We've got multiple ingress routes, as you can see on our low side on the left in blue. We've got data coming through from shares, which we can essentially have connectors that work to them in our MDSS, which is our storage security capability. We can have a more rigorous MFT approach that essentially starts to really manage the data and look at any pre-washing, sending it to a core, you may need it, and also defining who can actually access that data in more detail. We've also got the kiosk approach, which I said, as people bring information in off a USB stick. And we've also got that capability to plug the data in and push it through to a core. But as you'll notice, the thing we've got in common here is that core capability. So that core, think of it as, the sort of I suppose a bus conductor effectively, and that is then going to plug in a range of security enforcing functions depending on what that data is, and partly depending on where it's come from as well. It's up to you to define that, but we can certainly help you configure that. It's configurable in core. In this diagram, we've got it going through our net wall diodes, up to 10 gig in capacity, optical, nice and secure, nice and fast. And then what we've done is those diodes have the ability to be channelized. And what we've done is we've split the traffic based on type and how we configure the flows, that essentially we have a high side capability that is split between user workloads and system workloads. User workloads we've put on a different core, and with that we fed them into an MDSS capability, our secure storage again, and we're just going to use that to put out the data and send it to core to scan it as and when we require it to do so. We've then passed it through to an MFT, managed file transfer capability, for users to extract. The difference is here is that we've got a different core here for system workloads, and that's because we're using a different set of security enforcing functions. Now you might think, well, do we have to do that? Well, no, you don't. But in some ways, if you want to really look at the segmentation of data, which is a really key thing in cross-domain, this is a perfect way of doing it. You can add one core for user workloads, one for system and software workloads. You can split it how you like. But what we do have is it's then easier to associate the audit trail with this core for system workloads and that core for user-based workloads, essentially. It gives us great separation. George, anything to add on that one?
I think that's a great example where we can actually split the end users, people on the screen trying to make a file available from one environment to another versus very high load system workloads, as we call them. They're more like operating system patches, applications, installers, and so on and so forth, right? And then you keep them clean, even though they might think that going to the same gateway, they will have a different persona on the other side, a different owner on the other side, and also you have different SLAs, delivery times for these files. And that's how you should kind of differentiate when you're defining these flows. Regardless, at the end of the day, if you're using our products that our diodes are different and so on, that's kind of like one of the best practice solutions that I think you should have as a takeaway from here. Try to separate those workloads for you to be able to have a better manageability and audit trail on top of that one. If you're mixing them, it's going to be a bit of a mess to figure out if you're getting your files in time or if someone's not getting their files in time and so on.
Absolutely. And we see this now with a number of clients that we suggest splitting the workloads, and it's something that's gone down very well. It's a very simple concept in terms of prioritizing traffic, segmenting traffic, but it's that auditability. It just makes it a whole lot easier to manage. Okay, let's look at the next one. So this is CI/CD import. Now this is becoming something that we've seen again and again, and people want to take software capability from code repositories and we want to put it on the high side. Okay. Now, just before we go any further with it, people then have doing this for a while. People have said to me, well, we want to push code down the other way. Well, just bear in mind that comes with a whole host of other issues that possibly certainly outside this webinar, but you would need to think of. If you think about pushing code high to low, think about what's happened when it's landed on your high side environment, what it's accrued in terms of marking and classification, and what it may accrue in terms of additional markings and metadata and associated data you may be adding to it. Stripping that out, so you're not revealing what is the nature of that code and pushing it back down to the low side for a synchronization purpose, for example, can be difficult. So it's just something else to think about. I have known cases where it has been done, but there's an awful lot of redaction up front. So just bear that in mind. Let's look at the case where we're going to go import low to high. So we have a capability known as MDSSC. I'm really glad I got that right. It's a tricky one for me to get right. MetaDefender supply chain, software supply chain, nearly right. And what we can do is that we can essentially copy out a code repo and we can then push it through our MetaDefender capabilities. And there's a couple of things we want to do to it. We want to do things like a DLP capability, see if we can find any secrets that have been left exposed in the code. We want to look at a multi-AV capability. This is more looking at static threat, but we can also do other things to it as well. We can do a vulnerability scan. We can do a country of origin scan. There's a number of scans that we can essentially push the data into core to say, do these security enforcing functions effectively against it? We can then come back with the result of that combined security enforcing function capability and push it back to the repo. Now, we want to transfer that capability. If we go, actually, that's fine, we're going to push it up to the high side. We can then push it through our dioting capability and we can land it straight to another repo. Now, this does pose some challenges in terms of communication between code repos. You've got a diode in the way. If you know your dioting and your cross-domain capabilities, you will know that triple handshaking and coping with those layer 7 protocols that require that, and those layer 5 protocols can be particularly difficult. But we can look at how we do that in terms of spoofing the reply on the low side to say that's landed, that's a HTTPS 200. Guys, just stop there a second. I've gone off track, made it too complicated. Okay, right, I'm going to start this one again. Sorry. Okay. Okay, so second case we're going to look at is a CI/CD import. So this is very synonymous with develop low and deploy high. Now we've got a product called MDSSC, which is MetaDefender software supply chain. And what that enables us to do is to copy a repo from a code repo and essentially send it into MetaDefender core to have security and functions enacted against it. And this can be multi-scanning, country of origin, DLP to see if there's any secrets left exposed in the code. And we can also do vulnerability scans against it as well. So we can tailor make a chain of low side security enforcing functions. If we're happy with that and we want to send that repo up to the high side, we can send it through one of our NetWall capabilities or any other dioting capability. And we can then push that to a synchronized or a waiting code repo on the high side. Once in that high side repo, we can enact the same thing again. We can use our MDSSC capability, MetaDefender software supply chain, to pull capability out, to pull code out, and to then send it to be scanned by our MetaDefender core. We can also then enact our sandbox as well, which is an emulation-based sandbox. We can look at all code branches for analysis to see if there is a probability of something malicious in that code base. So a very powerful tool and something we're seeing more and more of in terms of people wanting to import codes and containers up to the high side for deployment purposes. George,
maybe if I can add one quick thing. Yes, thank you. So I think one of the things that is very important on the software supply chain part is that, yes, we can actually do a validation, if you want, the filtering in transit as you're bringing the source code open source. Not just has to be like custom built source code. It can be open source, it can be containers, as Val mentioned, to the high side. But I think it's equally important for us to monitor that on the high side and to like rescan it periodically. So the important part here is that, yes, there might be some source code that, I don't know, not detected, not like there's an open source that has like no vulnerability today. Maybe it's easier to explain that way, right? But they're going to have a critical vulnerability 3 days later, or like a week or 3 months later, and so on. So monitoring that on the high side and trying to identify what's new, it's really important. Same thing will apply for malware as well. There are more and more malicious packages, and this is the part that I think we add a lot more value as part of this flow, because I think this is a flow that a lot of people will implement with like an Artifactory to Artifactory will be an easy thing to achieve. But we're able to like scan for malware as well and periodically perform that rescan on the high side as well. I think this is something that you have to take into consideration. It's not just probably the biggest change comparing with the workload flows, where you're not just doing it in transit as you're importing the files, you have to do a periodic check on the high side.
Okay, now that's great, and some good examples of how we can do that. Okay, let's look at the last use case we've got here. This is an export use case. So we are going high side to low side. So let's just reverse how you look at this. So we're going right to left instead of the more traditional left to right in this case. But what we're really doing here is we're trying to expose the release capability, the release authority. And we've got something called managed file transfer capability that allows you to set up a 1 or 2 stage release capability and to set that up according to roles and functionality. So with that, we can have someone, might be an information owner, who can say this file can be released under these conditions. Someone can them to release those conditions, and then essentially they can allow themselves. Start again. So the last use case we're going to look at is the media export case. And this is where we are looking at the release control capability. So our managed file capability, managed file transfer, known as MFT, will essentially allow you to set up a release control mechanism. And this can be 1 or 2 stages or whatever you need it to be. And that is in terms of the roles and the functions they need to enact. What we can do is to essentially have that data be pulled from the MFT and then subject to whatever security enforcing functions your risk stance dictates. But really what we're looking at is looking at DLP to see if there's any phrases, any labeling, anything in the metadata, body of the text, header and footer that would preclude that data from being released. Then obviously, if that is true, if there is data that suggests that data should not be sent down to a lower classification, we really want to know who thought they could do that. And that's the other thing about this chain and using MD Core to enact this chain with our other capabilities, such as MFT, because we've got a full audit trail and we can see what role, what persona I can exfiltrate this data. Most likely, probably accidentally, but it's a trail that we can look at to see if that data should have actually been released. We can send it through our network capability, which is the on a low side element. So in this case here, we've just landed it on a low side export share. And again, what we've allowed them to do, or a set of users to do, is to take the data from that via our MetaDefender kiosk and then load that onto allowed. And this is something the kiosk can do. It can determine whether that set of USBs, that set of other media is allowed, and it can be transferred onto allowed media only. Okay. That's our export case. George, thoughts on that one?
A couple, if I may. So one thing I really don't like is to actually have like an export share, so to speak. If you just put it on an SMB share and allow people to retract it, like retrieve the files from there, you lose the visibility, right? So you can actually have either the kiosk solution on the low side and you can pull with the media. That means that you can force your end users to log in. You know exactly who's retrieving what files at what time and so on and so forth. Or you can also put MFT on the same side, on low side as well. So you can have like an MFT to MFT and you have the same visibility, the same audit trail, even if you want to put more restrictions in place and so on and so forth. So like all that can be achieved. At the end of the day, it's your decision. If you're extracting, let's say, logs, and those have been already redacted, and MetaDefender can perform that redaction, like IP addresses if you want, and all kind of sensitive information and so on, then you can put it in a folder and take it from there and move it to like archive it on the low side or things like that. But if you want someone that's like end user, I don't know, files, things that like productivity files, sensitive information and so on, you might want to have that paper trail or audit trail as well in place. So that's why like MFT or kiosk will come into place. And the last thing to mention here, and I think this is the most powerful part for us as well, right? Like we invested a lot more in intentional leakage. So as Val mentioned, like it might be something accidental where you're dropping the wrong file in the wrong folder, so to speak. I really hope it's not happening, but there might be things that can be, I don't know, legit accidents. But if someone is trying to put like white font on white background, high text behind an image, things that you're not gonna see, because sometimes you're kind of like, some people are even like printing it and then looking on the printing and so on, right? Those are what we call intentional leakage, and those are gonna get flagged way higher, right? So if someone is trying to like build kind of like workarounds to bypass that visual, let's say, review, that means they're doing a lot of extra work to be able to retrieve that file, and that creates a lot bigger alarms and so on our end. So back to Val's point on like, yes, we can alert on accidental and so on, and you want to prevent for that one to happen, but it's equally important to know who's trying to achieve that. And if it's actually intentional, if you can actually prove that they've done the extra work to be able to like get this out, then it's a way bigger discussion there as well, and we're providing that information as well.
That's great. So yeah, so the nuance is different. Again, this is a classic export capability, classic export chain. Yes, we want the data to be clean on the high side, of course we do. And you may choose to enact more filtering, you may choose to act CDR, etc. But the key thing here really is that data suitable for release, and is it allowed for release? If it's not, who's tried to release it? And as you land it on the low side, as George said, there may be other mechanisms with a high level of security, MFT is one, where you may want to really enforce some kind of roles-based access to really look at who can extract the data. Okay, George, over to you.
Yeah, so maybe one thing I think that Val perfectly hinted in the use case with the workloads, right? There's a lot more usage of cloud, or even not necessarily just cloud, but you're trying to replicate data from the low environment to the high side, right? And this can be done multiple ways, right? But there's also like, and I insist on cloud because they're like, I don't know, IC cloud, there's just community cloud, there's like top secret cloud, and so on and so forth. So there's a lot more usage of these environments in this project, defense project, intelligence community, and so on. And we provide a way to build that replication across boundaries, right? So for instance, you can leverage our MetaDefender storage security solution to monitor all those, we call them storage units, but at the end they're like file repositories if you want. And then for us to replicate on the high side or push them through a network, let's say through a diode, through an MFT, and then the users can retrieve it from there, and you have the audit trail as well, and so on. Our goal is to always try to like replicate from source to origin, potentially to use the same storage unit, a storage type, but doesn't have to be. So you can transfer from, let's say you have an Azure top secret cloud, so we can monitor like an Azure files or an Azure blob and push it through like a local NetApp. We can monitor let's say an ECR in Gov Cloud, and we can move it to like an Artifactory or like a on-prem container registry and so on and so forth. So like depending on how we want to build those things, we have the ability to have that plug and play solution, right? And that's the part, like the software defined plug and play is such an important part because it's such easy to manage and to like set it up instead of building custom flows and custom integrations. And the next thing, the next slide, it's exactly the same thing when it comes to like software supply chain, right? Or like if you want to secure your SDLC process, we like develop low and deploy high. This can be source code, this can be container registries, but this can be also like software applications from your vendors, right? As Val mentioned, we can apply not just multi-scanning, but file-based vulnerability assessment as well on those installers. But we can also apply SBOM when it comes to like open source and containers and so on. So once again, that flexibility in the platform for us to enable the right technology for the right file or for the file types and type of traffic, it's so important, right? And our software supply chain sits on top of that file analysis platform to offer those plug and play capabilities to monitor, but also replicate this, again, being like source code, like Git repositories or container registries and, you know, binary management and so on and so forth. And with that in mind, this kind of like a summary of all of that we started, or like this was kind of like midway slide, but this was like one of the key slides. If there's one takeaway from this presentation is this, right? That you should differentiate between the type of traffic you're seeing and to have like different flows for those ones, being system files, being CI/CD pipelines or productivity files, and for it to have like different manageability for those and proper reporting and auditability in place for all of them. Regardless what is you see at the bottom, what tiers, if it's like classified and classified or unofficial, official, depending on the country and how they define them, but secret of secret will remain the same and so on, right? Depending on what your classification level of the environment, you want to have proper workflows in place. And the idea for us is very simple. If there's a file, we will process and we will actually provide the right technologies to kick in and process that file. And once you have those pipelines, and again, this doesn't have to be, let's say, different environments. It can be the same gateway, with different hooks in different systems, but you're defining workflows within that gateway, in that bigger pool of servers, and we're doing the workers, MetaDefender core team about as workers. They're going to do the analysis and distribute the load and so on to process as fast as possible. Anything to add here, Val?
Yeah, so no, thanks, George. It's a really good way of looking at, I suppose, the scope of cross-domain and how it's changing. If there's three things I would ask you to take away, one is hybridization. So yes, there are still, I suppose, cross-domain gateways that rely very, very heavily on hardware, and they always will do because of the sensitivity and the location they're in, and that's fair enough. What we're seeing increasingly, though, is that cross-domain solutions need to be wider, need to be able to cope with a range of capabilities. They need to cope with multiple communities of interest. And because of that, a hybridized solution of software and hardware really seems a good way to go to enable that longevity of the CDS. The second one is, following on from that, is use cases. You may start off knowing what your use cases are, but inevitably now they expand. What happened, I suppose, 10, 15 years ago was that you would have lots of little stovepipe cross-domain solutions that, solution X did this, Y did this, and Z did a little bit of that as well. Essentially, now we want one solution, and we need solutions, cross-domain solutions, to be expandable. We need them to adapt and accommodate new use cases. The software capability, the plug-in, plug-out software capability, is a highly effective and resilient way of doing that. The last thing I'd ask you to think about is exactly that. It's the scalability and resilience. Single chains that are not scalable and are fault prone due to one element falling over are not the way we want to go. Often our CDSs need to be an intrinsic part of how we work, and to enable them to remain intrinsic and people not to find workarounds, they have to be resilient, they have to be fault tolerant, and they have to scale to allow the variation in workload volumes. Those are my three takeaways. Thank you very much. If you've enjoyed this webinar or you've got more questions, then please reach out to us. Please scan the QR code on the right to talk to an expert, and we can talk about our favorite subject, of which cross-domain is definitely one of them. We're happy to talk to you about that, not a problem. But we've also now got an updated blog on our website as well. So please follow the link there to have a look at that for some higher level insights into it. George, anything to add now?
No, thank you much for joining. Feel free to reach out to us. As Val mentioned, we love to talk about cross-domain, as you can tell already after this webinar. So any thoughts on this? If you have any questions, please put them in the chat and we're going to follow up with that shortly. Thank you much for your time.
Thank you.